All right. Okay, so we are recording now. So thank you for coming. And Jasmine, if you want to sit over my shoulder, you can, or you can just hang out there. That's okay too. All right. So what we're doing this morning is we're going to be reviewing lesson 709, which is polynomial functions. And I don't know if you've done that one yet. So I know at least one of you has done that, and I'm seeing, I think there's some confusion with the lesson, so that's why I wanted to spend some time going over it. So with this particular lesson, when we're done, I want you to be able to combine two functions using either addition, subtraction, multiplication, or division. And I want you to be able to create a new function by composing two different existing functions. And those, I think, might be some of the trickiest. So as a warm-up, if you would just spend a moment thinking about everything that you know about functions. I want to give you, I don't know, no more than a minute, maybe 30 seconds. Think about it, and then I want you to share out either through texting on the chat, which is okay because we can see that, or you can tell me and I can write it. But think about everything that you know about functions, and then share that with the group. Okay, so I've got, they can be graphed. Excellent. What else do you guys know? Ooh, that's a good one. So Annie just wrote they can be exponential. Jasmine confirms that they can. I don't know if you guys can hear her, but she confirms it. They can be linear.
We have an input and an output.
Oh, input and output. And output. Okay, excellent. Anything else?
Each input can only have one output.
Yes, so each input can only have one output. Okay. Each input, one output. They're expressed by using the infinite number of terms. Yeah. Yeah. All right, so they're expressed by using an infinite number of terms, algebraic terms. I'm editing you a little bit there, Sydney. I hope you don't mind. Using algebraic equation. And I'm sorry, my typing is, and Jasmine mentioned that they can also be used or expressed. You know, you learned during the first half of Algebra 1 that y equals mx plus b. And now when you're using some of this higher level math, f of x is equal to y. So some students get a little confused by that. And so f of x, you want to look super smart to your parents, smarter than you guys already look, and say, hey, look at this fancy math problem. Get rid of that y and insert the f of x, and your parents will be super impressed. And yeah, functions, functions can have more than, they can have 3 terms. Oh, they can have 2 terms also. But they can be big. So they can have 2 terms. Oops. 2 terms. Because we'll be getting into some bigger functions in Module 9, quadratics. Woohoo, that ought to make everyone excited.
Fun.
That sounds fun. I love quadratics. So, all righty. So when we are looking at more than 2 different functions, and in this lesson, a lot of times we're asked to combine functions. And we can combine them using either addition or subtraction. So we're going to start there. So if you look at the screen, we have 2 functions. F of x is equal to 2x plus 5, and g of x is equal to x minus 1. Now, what is the sum and difference of these 2 functions if f of x is equal to 4? Any ideas about how we would go about setting this up? You can either speak or type, either way.
Replace x with 4 for f of x and g of x?
Yeah, so when we retype this, we're going to replace the x with 4. So f of x becomes 2 times 4 plus 5. And then g becomes, g of x is equal to 4 minus 1. All right. What would we do next? Does that even look like a minus? There we go. And there's a couple of approaches that we could use here. Any suggestions? Okay, so we'll work with the part that has the parentheses first. Nice suggestion. Okay, so with f of x is 4, we end up with 8 plus 5. So Sydney, I took what you wrote and I just took it that one little step further. So we have here that when x is 4, f of x is equal to 13. And g of x, g of 4, that one's a little easier. So 4 minus 1 is 3. So if we write this puppy out, Yeah, okay. So Sydney wrote that the difference between the two is 10. You're jumping ahead of me, girl. All right. Oops, I didn't want to copy that whole thing. Bear with me.
Isn't it f minus gx equals 10? Is that how you would put the f and the gx together?
Yeah.
That was what I was confused.
Sorry. No. She, and Sydney, if I can speak for you, feel free to give me a signal if you want me to stop. But what Sydney put in the chat box is that the difference between the two functions is 10. So she did this part here, the second part. So if we are, and we'll come back to the difference in just a moment. So when we are adding these together, we have f of x, or f of 4, plus g of 4. And we, based on what we have up above here, we have 13 plus 3, and that is equal to 16.
Okay.
Okay?
Yeah.
And likewise, we can take this same information if we're looking for the differences. And I'm just going to scoot right over here. I am not having good luck with copying and pasting this morning. Got it? All right. So instead of addition, so difference means subtraction. We're going to take these same numbers, which we found out. We've got 13 minus 3, and that's equal to 10. So the trick, if we were to summarize the quick trick for solving these, what would you say? Or type? Either way. So a question that's been posed is, what if this already seems easy? So my question back is, if somebody else doesn't find it as easy, what would you suggest? So you're helping your good friend, and they're saying, I don't know what to do. How do I get started? I got letters everywhere, numbers, I don't get it. So what would you suggest? So PEMDAS, absolutely. So we want to use PEMDAS. What about solving for one function first? Maybe? It is what we did. Well, I'm trying to get you guys to think about what did we did instead of. So solve for one function, then the other. And then the final part was, okay, so we have remembering to place all x's with 4. All x's with 4, or whatever the number is. Sometimes, just to try to get you guys thinking what I'm thinking, this is so automatic for some of us that we don't think of all these little steps that we do, but we do them, and that's how we're able to solve these problems. All right, and then you substitute the numbers that you found and solve. All right, good. All right, so how about multiplying? How is this going to be any different? Is it different?
No.
No, why not?
Well, I mean, it's different that you're not adding stuff, but I don't think, if I remember, I don't think it's different than like the process of doing it.
It's really not. You're right, Annie. So what we do is, in this particular problem, we are given a value for x, which is 8. So we're going to replace each x with 8. And then solve for each function. You guys see what I'm doing? And then we'll multiply those together. So Jasmine, if I were to rewrite this first part, function f. Huh?
What would you put?
Yeah, what would you put? I know that
8. For instance, 8 plus 5.
8 times 8 plus 5.
Yes, 8.
And what does that equal?
I used to know all my multiplications.
What's 8 times 8?
Yeah, like 64.
Yep, 64 plus 5 equals 69. Okay, and then, nice. All right, so Sydney says, you know, this looks more complicated, but it's basically the same. And I agree, it does look more complicated. And I think a lot of times as math students, and let's face it, I've been a math student, we see all these symbols and variables and we have a minor little freak out moment going, whoa, what are they asking? So it's taking that time to step back and go, wait a minute, I know how to solve for a function. I can solve for 2 functions. Can I multiply those numbers together? Oh yeah, I can do that. All right, so this right here is function f. And then function g is 7. I don't even think I need to bother writing that out, do I? So 8 minus 1 is 7. All righty, so now we're going to multiply these 2 big guys together. Somebody with a calculator, what's 69 times 7?
483.
Thank you, 483.
I did that on the calculator, just so you know, I'm not that smart.
You know, you didn't have to say that last part. You would have been good with
Or
that.
no, I totally worked that out on paper. That's what I did.
Okay. Either way, that all works. All right. So here's a practice problem for you guys. So solve this problem. We have f of x is equal to 3x plus 10, and g of x is equal to 2x minus 1. Please evaluate when x is equal to 5. Those are nice numbers there, Sydney. All right, nice job there, Miss Annie. So I'm going to type down, actually, Sydney, I'm just going to copy. Can I do that? There we go. I just want to copy and paste what you have. That's a little bit faster. So Jasmine, do you have the first function?
25.
Yeah, nice, 25. And then we take 25 times 9. Second function is 9, so 25 times 9 is 225. Awesome. Awesome, thank you. Does that make sense?
Mm-hmm.
Thumbs up. You girls seem to be getting it. All right. Now, division. And you're missing a problem here. So if I use these same problems from before, I'm going to copy and paste. Sorry. When I put these together, sometimes I go faster than myself. All righty. So when we are dividing, it's very similar to the multiplication. We're going to take those numbers that we have, and even when it looks fancy, there were some, let me see if I can find my annotation here. So I know in the lesson they had f of x. How did they write it? F of x. I don't even think it was that basic. Something like that. And, you know, that can look intimidating, but don't be intimidated by that. Because when you're given these specific functions, you can replace that f of x. And these are the same numbers, the same basic function that we had before. We have f of x is equal to, that's not the same number. Ignore my last statement, please. So when x is 10, well, let's see. So the first one, if we substitute, we have 3 times 8 plus 10. And that equals what?
I think.
What did you say, Annie?
34?
Yeah, 34. And you see where that comes from, Jasmine? Okay. And then 2 times 8, we have 16. And this is going to be an ugly number. I'm queen of ugly numbers, just saying.
Ooh.
Is 15. So what is 34 divided by 15? It's not 0. It's not a whole number. Here. Okay. It's an ugly number. Almost. Okay. So Annie says 2.26. Sydney's got 1.8.
2.26.
Jasmine has 2.26. And I will say that's what I got also. Did you put 34 divided by 15? I'll take that as a no. That's okay. That's all right. That's all right. As long as you know what happened, that's cool. Okay? So dividing functions is very similar to what we've been going over. All right, so here's a practice as soon as I get my mouse back. So practice dividing. Can you guys see that enough? Is that better? Okay. All right, so if f of x is equal to 2x plus 8 and g of x is equal to 3 minus x, find f divided by g when x is 5. So Annie, is that the whole thing? All right, so Sydney has G. Okay. Annie, I'm just going to go back to who responded first. So I'm keeping track, all right? Annie, what does your 6, where's your 6 coming from?
Yeah, I just think I did. I think I'm looking at Sydney's thing. I didn't see the minus. I thought it was 5 minus 3. So I think I got that wrong.
Oh, okay. Okay, so Jasmine is telling me over here that come on, mouse. That f of x is equal to 2 times 5 plus 8. So that's equal to 18. And then g of x is going to be 3 minus 5, which equals negative 2. And so 18 divided by negative 2 equals, you got 2 out of 3. So if you put in that calculator 18 divided by, and then you go right here, where the negative is on this one. I know each calculator is so different.
-9.
-9, awesome. You girls are rock stars. Okay, did I change that too fast? All right. Okay, so composite functions. I think these get confusing for students. So a composite function is when you are inserting one function into another. And you have to solve that function, the inserted function first, and then you have to do some other manipulations. So for example, and it looks funky. It looks like this guy that's at the end of here. Find f to the function of g of 4. So the first thing that you want to do is you're going to take that 4 and you're going to substitute it into the function g. So you can't do anything else before that. So when I substitute 4 in for g, I end up with 8 minus 5. So g of 4 is equal to 3. All righty, so now, is everybody with me on where that came from? You ladies seem right on top of these functions. So then, when we're looking at the next step, we're going to go back to f of x. And we're going to substitute the 3 for x from that original function g. That's where this 3 comes from, is right here and here. And then we add the other number. So in this case, it's 3 plus 2, and that is equal to 5. So the trick to solving the composites is to solve the function that is on the inside. When you have that answer, you then replace the x value in the original function to come up with your answers. Not that hard? Okay, you guys.
Okay.
Okay, you ready for practice? We're almost done. All right, okay. So here's a practice problem. So if a of x is equal to 4x minus 2, and b of x is equal to 12 minus x, find b as a function of a3.
It sucks if you get the first one wrong, because then you got the second one wrong too.
Yeah. So, no. So what is, let's look at function a first.
Oh, I put it in the wrong one.
Ah, so Jasmine is over here. See, you guys, it is confusing.
Because like it says B.
B is a function of a, and we were doing the opposite before. So when,
Oh, am I supposed to be doing B first? Oh,
no, a first.
okay. And that equals 10.
Yes,
Yeah, 10.
yes. So we're good there.
Yeah.
Yeah, so now, so x becomes 10 in this particular problem.
Oh, that's what I did wrong.
I just did
I
4
see. That's
plus
2.
7.
What was it you did, Annie?
I did 4 plus 3, so I got 7. So my final answer was like 5. Or no, my final answer was 7. But yeah.
Okay.
That wasn't right.
Wait, do you add the 10 and the 2 together, and then that is what equals BA3? Or what? I'm confused.
Okay. So the inserted function is A.
Yeah.
That's this guy right here. So when x is 3, we solve for A and we get 10.
Yeah.
Okay. Now B is a function of A. So we substitute
The 10, because that's what the equation equaled in the first equation for A.
yes.
Yeah.
Yes. So we substitute this 10. Let me get my little handy dandy. This 10 goes here. And when we look at the original equation for B, we've got x is, or 12 minus x.
Yeah.
So that's what I wrote here. I've got the 12. I know that I need to substitute the right number for x from the first function. And then I do that math and I end up with 2.
So that's the final answer for the BA3?
Yes.
Okay, now I understand this.
Yeah. It's tricky. No, this is the final answer. Oh. Okay, let's do another one. Let's use this same problem. And let's have x. I like some repetition. So what's a good number for x, Jasmine?
5.
All right, so Jasmine wants x to be 5. So find a
For that same equation.
yeah. We're just using a different number.
$18, yeah.
Mm-hmm.
And then you plug that in for
Oh wait, yeah.
B,
Mm-hmm.
B18.
-6.
Yeah, so you substitute it in to that value for x, and you get 12 minus 18 is equal to -6. These are tricky. These are
Yeah,
tricky.
now I get it.
So that I have, well, before I move on, any questions? No? Okay, I have some practice problems as an exit problem. So if you would take a moment to write these down, because I did not write the problem down in the exit slip. No, there's an assignment. 7.09 virtual session, I think it's called.
9.
So using these functions, f of x there, if that's helpful. F of x is equal to x minus 8, and g of x is equal to x squared So find f of x plus g of x. Pretty much. We're adding them. We're subtracting them. You probably need a value for x, don't you? That might be helpful. Good point. Oh. Sorry. Okay, so let's use I had that lump sum is equal to 4.
4. Okay.
And because I thought I had the number written down, but I don't see it here on my paper. So there might be some messy numbers. So be prepared for that. But that's okay because life is messy sometimes. And, you know, when we go shopping, we don't go shopping with whole dollars. We get pennies and we get nickels and dimes. Occasionally we get a $2 bill. So, you know, who gets that anymore? All right. But answer those questions.
Okay.
Okay. And submit them into the virtual lesson on 709. And anyway, that's it.
Well, how many